I've wiped everything out as usual, so let's go ahead and start by creating a new block. And we'll call this SCL demo because that sounds good to me. And let's go ahead and set this up as a function block. And the language on this guy is going to be SCL. Now, if you notice, I'm programming on a 1200 simulator right now, and these are the only 3 languages offered on the 1200 model PLC. So for the next section, we're going to have to switch over to the 1500, create a new program to work in, and that's going to give us a couple more options. But there's no reason we can't finish up in this. So let's create an SCL program block. And boom, there it is. And let's double click on that and look at that. We've got, this is nice, okay? We've got templates for our basic program structures up here. So this really will help you if you get into programming and you're like, oh man, I don't remember how to define the if statement. You know what? It basically does it for you. So let's just click on if and look at that. It pops right up and says if some condition, then, it gives you a place to do something, and then it's got an end for the if statement. All right, so that is really useful. Well, we in the last section, we used function blocks to set up an alarm, and that alarm was evaluating an e-stop. So let's go ahead and look at that same concept here, and we're going to program the same alarms using SCL. So real simple stuff. If, well, what's our condition? We're looking for the e-stop to be present. So I'm just going to type out e-stop, and we've still got that tag defined. So if e-stop, then, okay, now we're going to do something. And let's go ahead and we'll select all of this. Then we're going to set our alarm, and we want to set our notification bits equal to 1, right? So we'll go ahead and start with the e-stop alarm and space, watch this, colon equals 1. Okay, now that colon equals, that's how you do assignment in here. So we're setting that equal to 1. And then I'm not done yet. If e-stop, then I also want to set our e-stop notification. So I'll type the first couple of letters and then select that from the box. Colon equals 1. And then if I just try to go down here, you see how my 1 is still red? That's because there's an error. Each one of these lines, each finished statement has to end in a semicolon. Like you see up here, my if statement, it says if e-stop then, and you notice there's no semicolon. But follow the line down because all of this is part of the if statement. The semicolon is here. These two statements, you see how they're indented in? Those are nested statements, okay? Those are statements inside of another statement. So each one of these statements has to end in a semicolon, and this if statement, which I can expand and contract to show everything in it, that also has to end in a semicolon. So if e-stop, then we want to set the alarm and set the notification. But here's the thing. If we leave it like this, then the e-stop notification is going to constantly be set as long as this e-stop is energized or closed. And we don't want that, okay? So this is something that we want to happen one time and one time only. Okay, so we have to be a little bit more creative about how to set that. And I'm going to show you a way that we can do it. So if e-stop and here I can set some other condition for us, okay? So let's say that we've got an e-stop alarm trigger bit, something that tells us that these things have already been set. So I'll just take ALM SET, and that's going to tell us that the alarm has been set. So right click, define that. That's going to be a bool, and that's going to be local static memory. So define that, and here we're looking for that to be true, but we want to look for that to not be true. So I'm going to type not in front of that. Okay, so if e-stop is true and our alarm set bit, okay, this alarm set bit, what's that? Well, I'm going to create that alarm set bit. I'm going to, I just defined it, but I'm going to set that right along with my alarms here. So pound ALM SET colon equals 1 semicolon. Okay, so now that bit right there is going to be set. And once that's set, from then on, whenever we evaluate this, it's going to say, oh, nope, it's set. So it's going to skip over this. Since this is true, but this right here will not be true on the second scan, it won't try to set those again. All right? So I just need to remember to release that at the right time. So this has created our alarms. This has set those alarm bits. Now we need to have a way to manage those alarms. So let's come down here. Now we're looking for alarm reset. If AL, and there we go, we have our alarm reset. Then what do we want to do? Well, now we want to change our e-stop alarm and our e-stop notification and our alarm set. We want to set all of those to 0. So I'm just going to Control C, copy all of that, Control V, paste it in here, and then I'm going to replace those 1s with 0s. Okay, that's really simple. And then come down here, and this will be my end if, and there's an underscore, end underscore if, semicolon. Okay, so the alarm reset right now will wipe out all 3 of those, but what if the e-stop is still engaged? Okay, in that case, I don't want to wipe all of these out. So we'll go ahead and say if alarm reset and not, quote, e-stop, then, and now it'll do this. So the alarm reset will only reset those if the e-stop is not pressed. But what about that e-stop notification? Because we do want to be able to reset that independently. So let's copy all of this, and I'm just going to paste that whole block here. So let's try this. If alarm reset, or, and we'll change this e-stop to AL, whoops, I didn't get it selected apparently. Let's try that again. ALA, okay, alarm silence. If alarm reset or alarm silence, then we want to go ahead and reset the notification, but we don't want to reset the set bit. The only way to get rid of our set bit is if we do a proper reset, which means there's no e-stop. We can get rid of the notification only by pressing alarm reset or alarm silence, but do we also want to check for the alarm to be present? If so, then we can also put and e-stop notification. So ESTOP notification. Okay, so if somebody presses either of these 2 buttons, alarm reset or alarm silence, while there is an active e-stop notification, then we will reset our e-stop notification. Okay? So now we've got a way to set the alarm bit, set the notification bit. That will only happen for one scan thanks to this alarm set bit that we created here. Then we can do a proper reset once the e-stop has been disabled. Then we can come in here and reset the alarm. That will get rid of the alarm, the notification, and our set bit. So that resets this whole process. On the other hand, if the e-stop is still pushed and somebody presses the alarm reset button or the alarm silence button, as long as the e-stop notification is already set and energized, then we'll go ahead and we'll reset that back to 0. Okay? So that's the idea of this logic. That's our alarm. Let's go ahead and run it up and see how it works. So I'm going to come over here into our main. Let's drag that SCL demo down here and drop it and let it have its database. And very simple block right there, and we should be ready to go. So let's go ahead and click our simulate button, hit OK, start search, find our instance, hit load. It's always such a process to start up the simulator, but that's just because it gives us so many options. So hey, maybe that's a good thing. Finish. Okay, we're up and running. Let's go ahead and click monitor. And actually, we couldn't care less about monitoring the main, right? We want to see the SCL demo. So don't go offline. Let's come over here to our SCL demo. There we go. Man, I keep double clicking that. There we are. And let's monitor this. Okay, so now we're online with this. And you can see it's really kind of hard to tell what's going on. There's not something anywhere, even while we're monitoring, there's not something that we can look at that really tells us what these things are set at. So that's a bummer, but that's okay because that's why we have watch tables, right? So let's come down here and add a new watch table, and we'll be able to test that logic in here. So what do we want? We want to monitor our e-stop. We want our alarm reset. We want our alarm silence. And then we want to check our 2 alarm bits. So we want our e-stop alarm and we want our e-stop notification, which I passed. Where is it? Let's see. There we go. E-stop notification. So let's activate monitoring here. Modify value, let's send in a true, and just like that we've got our e-stop alarm and our e-stop notification. Let's disable our e-stop, and our notification and alarm remain. Let's hit our alarm silence button, so we'll send in a true on that, and as soon as we did, our e-stop notification went away. And let's try sending in our alarm reset. And as soon as we do, there we go. Our actual alarm got reset as well. And just to test a little bit further, let's go ahead and true up our e-stop one more time. And let's try to silence the alarm while the e-stop is still true. And yes, our notification bit disabled. Let's make that false again, and now let's try to reset our alarm while there's still an active e-stop. And sure enough, you see the alarm stays on, but our notification did not come back on. That's a good thing. And now we can disable everything. Actually go ahead and put our reset back on, and there we go. That got rid of our bits and everything's right back the way we started. So, and let's go back into our SCL demo, and we've got one more piece of an if statement that we can throw in. So let me show you how else works into this. let's go ahead and pull down a formatted statement for if. So we've got if then, and let's see what this does. So we're going to say if switch, and we've already got our switch defined. That's good. Then let's say val1 colon equals 0. Or actually, let's make it something more interesting. Let's make it negative 100 semicolon. But what if switch is not true? Okay. Else, I can come down here and my val1 will equal 100 semicolon. Okay, so we've got this else. So if this is true, do this. Otherwise, do this. But it's going to evaluate this condition, whatever that condition is, and one way or another, it's going to take some action. So I'll show you the test for that real quick, just so kind of proof of concept, so you can see that it works. Even though with this type of programming, we can't really see how it works. Let's pull up our watch table, and I think we're in here. And we'll go ahead and pull up our switch. So it should be right around here. And then we'll go ahead and pull up our val1. So right now, val1 is set at 100. Why? Because, well, our switch is already disabled. But let's go ahead and enable that. And as soon as we do, pop, that thing goes to negative 100. And if we false it back up, boom, right back to 100. So that is just one more nice little elaboration on the if. And you can nest if statements within each other. So I can have if switch then, if something else then, if something else.